Hi everybody, in this video I want to talk about setting up a linear light workflow in Maya. Okay, so why do we want a linear light workflow? Well, if we simplify sort of how we want to really do our computation, we know that light is linearly additive in the real world. So that's how we want to do all of our computation. Anytime we want to render or composite an image, we want that to happen in linear space, okay? And in order to do that properly, we need to make sure that we're giving it the right kind of data in and we're getting the right kind of data out. And that means linear in, linear out. Anything else is going to muck up this space. And so what does that mean, and why would we have something that would muck up this space? Well, one thing we need to understand is that every time we look at an image, we're looking at it in what's called the sRGB color space. Now, don't worry about that right now. I'll probably have another video about that. But what it means is that it actually darkens the image before it gets to the monitor, right? Before it reaches our eyes. And so what we are looking at looks right, but that's not how it's stored. It looks a little bit more like this, okay? We have looks right over here, which is how we're used to seeing images on our monitor, which darkens down whatever is thrown at it, right? So based on some decisions made a long time ago, most of our files, our image formats, are stored in a pre-lightened way. So like they're pre-processed so that they look right when they get onto the monitor. So that if we were to just probe into our hard drive, they'd actually look like this. You can notice the brightness difference. It's a little bit lower contrast. So, you know, we would kind of say this looks weird and this looks right. Okay, so if this is how it's being read off of the drive, that can cause problems when we get to the math part of the rendering. Okay, so let's take a look at what this means for us. This is sort of the default methodology of how Maya handles things when we turn on linear light rendering. And we'll walk through that process in just a moment. But what it means is that while we look at this, and this is what we perceive looking at the monitor as this wood grain texture, nice and rich color, it actually gets read in right off of the disk without that sRGB correction. So we have this lightened image that gets whatever lighting we have applied to it. And so that when we look at it again, we get this. Now, a lot of times we get used to this, so we try to work our way around it and we adjust our lighting to fix it. But if we just switch a few things around, it makes this so much easier and a lot more logical. All right, so let's see what that path looks like. Okay. What we want to do is we want to convert this from its sRGB correction directly into a linear light space so that when we are doing our calculations, they're being performed properly with these colors. And that pretty much evaluates into a much more pleasing result. Notice we don't have the highlight, okay? One of these things, and this is just a horrible approximation, but one of the things that we'll notice when we do this is how much more controllable the light becomes. And it's a quick realization that we shouldn't be used to this, that we shouldn't be used to trying to fix it this way when we can really get it much easier this way. So how does this all work inside of Maya? I have a quick diagram and then we'll jump over there and just get our hands dirty. Okay, inside of Maya, you know, this is inside of Maya, and out here is what's stored on our disk. So over here we have any kind of image format, pretty much. PNGs, JPEGs, TIFFs, Targas. Most of these formats that we're used to are stored in this pre-corrected 4 sRGB color style, right? So what we want to do in Maya is set up some rules so that if it sees that this file coming in is sRGB, it wants to convert it to linear before handing it off to the rendering. Okay, and that's so that the rendering can happen in that linear space again, and so that we can write that out again as linear to our disk, which will give us a lot more flexibility in post. But we also have to remember that we want to see this so that it looks right and not look weird. Okay, and So as a general rule of thumb, if we look back here, okay, see, this is designed to be shown on an sRGB monitor by default, so it's bright. One thing we'll notice about the linearized images is that they look dark. Okay, so there's two different kinds of look weird that we kind of want to keep our eye out for, so that we can correct for that, so that we make sure that our pipe is nice and proper. Okay, so the two things we want to really do is make sure that we're processing our images properly on the way in, and that we're looking at them properly on the way out. And of course, we're saving them in a linear space. So let's see what all of this means in Maya. Okay, so here we are in Maya, and I have a pretty simple scene here: a little desk lamp, a desk, some spheres with some textures, a little chip chart, things like that. I mean, I'm just going to go ahead and launch a render right away. And this is the default render setup that Maya gives us. And we'll notice a few things. Forgive me for the speckly shadows, but you know, I just want to get through these things as fast as I can. One thing you'll notice right away is I want to point out, first of all, that our lights in here, I have a light inside the bulb here, and I've got a fill light in here, and I have one light giving us green cast as if it's coming from this shade. There's no final gather or global illumination turned on here, but all of my lights have quadratic fall off, and they're adjusted as such, right? So as I'm sure you're aware, if you're watching this, that if you've dealt with quadratic fall off before, you'll always be in sort of a bind, right? By default, like, I want this to be nice and well illuminated over here, but at the expense of what? A giant highlight here. Okay, so we can alleviate this by minimizing this light and trying to bring this down to a value that's going to give us you know, less of a harsh highlight on this desk object here, but we're also going to kind of lose a lot of illumination off to the side, right? And we still haven't lost that harsh highlight. And now we're kind of getting into that darker zone that I don't want to be in. So even if I'm trying to split that difference, we'll find that we're going to be in a kind of a difficult situation no matter what. So once this renders out, I'm going to store this, and we're going to go through the process of converting this over to a linear light workflow. Now, I'll warn you ahead of time that if you try to set up everything first before activating a linear light workflow in Maya, you're going to have a lot of work ahead of yourself in adjusting all the lighting that you've already set up. Okay, so this is a nice simple scene with 3 lights, so I'm just going to be able to do that pretty quickly. Let me store this. But you'll see how you can kind of quickly get behind the 8 ball with this. All right, so let's take a look at our rendering setup here. Okay, bring in my render settings here. Now you'll notice I have my rendering canvas set to the one I want to use. So let's do a few things right off the bat. This is pretty much the default setup here, minus the fact that I've switched this over to 720p. Right, so I'm just going to enable color management. Okay, and now if yours isn't set up this way, I would totally recommend setting it up the way this is here. Right, what we want to do is say that our input profile is sRGB and our output profile is linear sRGB. Okay, that essentially means that what's coming in is in this sRGB format, and we want to get that to a linear space. And what we're going to kick out is going to be linear. Pretty straightforward. With that checkbox, we can start solving a lot of problems very quickly. Here, I'm just going to give myself a name here, shot 01, and make sure that I'm going to render to OpenEXR format. Now the final thing we have to do, just to do it now before we forget it, is to swap over to our quality tab, down to our frame buffer, and by default we're set at this 8-bit file format. This is an integer-based file format with 255 levels of color for each channel. Here, you have an RGBA short, right? This is another integer-based format. It just gives us more values. What we really want is this RGBA half, this 16-bit, right? Looks the same except one is short and one is half. Half is what we want.
This is a full floating point color format. The 32-bit just gives us more accuracy, but it takes up a lot more drive space, and most of the times it's not really worth the extra effort there, the extra storage. Okay, so pretty simple, just really quick. Switched on my color management, made sure I was sRGB in, linear out, and switched over to OpenEXR and turned on floating point processing. That's all we need to do for there. Okay, so let's do another render. Okay, now as this is rendering, I will point out, once this is complete, we'll take a look at what that input profile is actually doing. Okay, so already we can see that we're getting a better handling of things here. Right, we don't have that big highlight, but we are dark over here. In fact, it looks kind of dark overall. If we switch back and forth, it's definitely dark, right? Well, the one thing we haven't done is this step right here, okay? We've created these conversions, and now our computation is happening linearly, except now we're just skipping this step. We're jumping right over here to here. And if we remember back, okay, we're basically looking at this darkened version, right? So what we need to do is make sure that we're seeing this the proper way, right? So as you remember, we can look weird in two ways, and we can look at a really clear example of that right now. Okay, so we need to switch to make sure that what we're seeing here is getting converted. So up here in the render view menu, we can go to display color management. Okay, so in here you'll see that our image input profile is sRGB and our display color profile is sRGB. Well, this is wrong right now, okay, because what we want coming into this is linear sRGB. Okay, and that makes our output sRGB, which is how we identify our monitor. Okay, so already you can see how this looks much brighter. Okay, so if we swatch over here, you can see how much brighter that our previous one has become, right? Because we're converting this, so it's getting sort of a double conversion. Okay, so once we're in linear light, we want to be making sure that we're looking at it the right way so that it doesn't look weird. Right, so even though, again, it's brighter, we're still holding on to these highlights. So how do we correct this? Well, this is now where we need to alter our lighting, right? If we had lit this for sRGB rendering, then we're kind of lighting it in the wrong way. So I'm going to run through, and I know that I've sort of predetermined some of these values, 350. Almost half is across the board. I can use almost half the values because with the light being calculated properly, we just don't need as much of it. Okay, so I've made some changes to the three lights, and I'm going to go ahead and render this again. All right, so as this is coming in, you can see already that we've got less brightness here, and that our image handling overall is much more pleasing. Okay, right? So we're able to hold this up, and you know, one thing that you'll notice about this kind of lighting is this reacts so much more like the kind of lighting that you expect to see in the world around you, right? As you put a desk lamp on your own desk. Now we have one more adjustment to make, all right, and this has to do with how our textures are being handled. Okay, everything looks right, everything feels right about this. The one thing we have to do is pop over to our hypershade, right? And you'll notice here, if I just load in my chip chart image here and look at it, here's this color profile setting. Okay, it says use default input profile. If you need to override this, you can do this here, but in general, you shouldn't need to do that. The one thing that is giving us a little bit of trouble is actually this base right here. Okay, let's take a look. You see how light that is, especially in comparison to the green shade here. If we were to switch over here and adjust our colors management back to make sure we're looking at it right, you can see how this and this green are matching. Okay, But when we're rendering here, they're no longer matching. This one is much lighter. Well, the reason for that is because of Maya's color picker, which does not get linearized when we pick solid colors, right? So this color here does not get the conversion. So we do need to make that adjustment, okay? And the way we do that is actually in here and using a gamma correct node. Now you'll find this in the utilities, scroll down, gamma correct. Okay, here it's kind of an odd workaround right now, but in this value here, you can add that color, right? If you just go into this color swatch, right, you'll notice that it gets loaded into the swatches if you just go in and pop out. See, it gets loaded to the top of the range there. So we'll hop over to our gamma correct node, go into value, we'll choose it, and now we're just going to drag it right onto that color swatch again, like that, no problem. Now, that's not quite the end of the story for this color. We still need to make that a gamma adjustment. Now in here it says gamma, and what we're going to do is the inverse of a 2.2 gamma, which is pretty close to the sRGB color space. So if we know what the inverse is, that's 1 divided by a number, right? So 1 divided by 2.2 gives us 0.454545. Okay, now that's going to be, as you do this, that'll probably be a number that you can recognize from time to time. So I'm just going to pop it into all three values here, and you'll notice our color swatch changing in color. Okay, so now we have that nice dark rich green. And one thing I also know is that my one bulb in here is also affected by the same color. So since I've got it loaded into there, I'm just going to go ahead and drag it right onto that bulb color as well. Okay, now I think that takes care of my single solid colors in the scene. And you can see that by using texture maps, we get around a lot of extra work, right? It's those solid colors that'll get you sometimes. So let's give it one more render here. Let's pull up our render. I'm going to go ahead and store this one and render this one last time. Okay, so we should see a much better match here. Yep, there we see it. So between the base and the shade here, we see a much better color match. We see a complete handling of all the data in the highlight here, and we have a nice handling of the light fall off, right? You can see the difference and sort of the richness of color we get back just by making that gamma adjustment. Okay, so from here, where we had that issue of the blowout going dark, having a little bit maybe extra contrast. Now this looks like a nice rich thick image, but in reality it doesn't give us much place to go, whereas this image we can go many places. Right, so now that this is all set up, what we want to do is when we want to render it, we can't just save this image out. I mean, we can, right? Let's see what that looks like. Lamp. I'll just save that right there. And in my images, I'll pull that up. Okay. And you'll notice that it gets saved without that correction. Okay. So there's a couple ways around this, right? I mean, you could just go ahead and save image as color managed, right? Which would solve that problem. Save image, lamp underscore color managed. I'll save that, and you can see that here's our lamp. Ooh, snap. Not color managed. I forgot to apply that. Save color managed. Apply. There we go. Apply and close. That one got me. Save image. Yes, of course. There we are. So there's what we expect to see, right? That's the expected vision. Okay, so that's what happens when you save it out of there. You just have to be careful of whether you're saving this as a color managed or a raw image. The gotcha is that you can't save OpenEXRs from here. So we do have to do a quick render, and I'll just do a quick batch render. And this will render out with Mental Ray. And if I have some forethought, I will cut this out of the video before I upload it. Okay, so through the magic of editing, that was rendered very quickly. And we're going to take a look at that now, right? So this is our color managed save that we just saw. Okay, here's our EXR that we just batch rendered out, right? You can see rendered at full size. Now, again, looks weird, right? So here are the three, we have the flavors of looking weird, right? If we look at these together, right? We have the image we expect to see, and then we have the overbright image and the underbright image, okay? So this is a linear image displayed on an sRGB format, and then this is a linear image saved in a format, in an EXR format, which does not get converted in the same way. So these are both things we don't expect to see, and this is what we do expect to see. Okay, so those are just things you got to keep in mind. Now, if we swap over to Nuke real quick, we can load our image in here. I'm just going to go up and do a read, and I will find our open. Okay, and we'll see that as I hit the number 1 here on my keyboard, we go right to seeing our image looking fine and wonderful in its full glory of quality, right? And you'll notice that our EXR gets properly interpreted as linear, okay? And so here's this flexibility I was talking about. We can see that with that floating point image, we can get all of this wonderful detail down into the shadows and all the way up into our brights, okay? One more time, we'll go over the steps involved in getting here, okay? So the steps we went through, we're going to our render settings, common, enabling color management, setting our input profile to sRGB and output profile to linear, and then getting ourselves open to OpenEXR and making sure that we're rendering to RGBA half 4:16. Okay, and then the changes we had to make in just our viewing were to go to our display, color management, and then over here and making sure that our input profile was linear sRGB, just as it is over here, right? So we basically round trip ourselves from an sRGB space to an sRGB space and making sure that in between we're linear out and looking at it again, okay? So with that, thanks for watching, and I hope that helps answer any questions.
Shut up and sit down.